So, year 11, just an update with the test. It's still Monday. However, we've taken off content, so you won't be tested on 5.4. So today we're gonna finish with 5.2, 5.3. Originally, there were questions in there related to 5.4. You won't be tested on that. You'll be tested on up to 5.3. Okay.
Will there be a practice test?
The practice test is here. It's going to come out soon. Once we're done here. Okay. Any questions with that? So I'm going to sketch a few quartics. First one here is y equals negative over 2x minus 1 to the power 4 minus 5. Just by looking at it, can anyone tell me what the turning point is straight away? Okay. Okay.
1 minus 5.
Okay. It isn't minus 5.
Oh.
Okay. But what do we need to do with what's in the bracket? Remember, to find out what's in the bracket, our turning point, can I get to equal 0? 2x equals 1. X equals half. Okay, so that's the first thing. It's turning point. Y-intercept. So x equals 0. Shape all working out. What's in the bracket, Zach?
-1.
It's -1 over 4. If I have a negative of a -1 to the power 4, Nathan, what do I have? Do I have a positive one or a negative one?
Yeah, positive.
Okay. No. Next. It will be a negative. So negative, there are 4 negatives. So whenever you have an even set, whenever you have an even set of negatives, because that's a plus and that's a plus. We have a plus, but then we're inviting another negative. Yeah. Okay. And then becomes -6. You're right. Okay. Okay, x-intercepts. Y equals 0. Can someone please solve that for me right now? Who wants the lolly? Solve that.
5 plus 1 on 2.
Okay, what goes left first? What do we move over next? Negative? Over -1. Over -5.
So then there is no anything.
No x-intercepts. Okay, can someone explain why Emily says there's no x-intercepts? Okay. Okay. I can't possibly have something like a squared. Just pretend that's a squared. What if that was one times one, it's one. If it's negative one times negative one, it's also one. It works with any power that's even 2, 4, 6, 8, 10. So just be careful of that. An even power can never equal a negative answer. Okay. So when we do our graph, I'm not going to do it exactly here. So if this is half, and this is 1, and I'm going to make this negative 5. Our quartic, is it going to go up or down? We have an overall negative in front of the x, a negative quartic, so it's going down. So it's going to cut like that, and our y-intercept is that negative 6. Okay, we're not really sure exactly even if it does one of these. That's when you find out in semester 2 when you do calculus. Okay. Okay, who's feeling confident about next week's test? I tried and I failed. Sorry? Yeah, but you've got you can see me on Thursday. If you need any help. Yeah. You know where I live? Okay, where do I live?
In this block.
In the woodwork room. Okay. In T1. Yeah. Arita knows where I live exactly. I think I know where Amrita lives. Okay. This is on YouTube. All right. Okay, we're going to sketch this one here. In this form, what can't we read off straight away? The y-intercept and the turning point. So y-intercept, not great. Turning point, not great. But what can we? X-intercepts, thank you, Nathan. X-intercepts. You can see clearly there's an x-intercept there. For this one, if it's x plus 3, x minus 3, and 3 minus x, just move the x over at x equals 3. When we go over here, 1, 2, 3, there's one there, and one there. Now, there is a clue on the actual shape of this. Now, is this a upside down? I've got to bottom it out a bit so it's not a quadratic, it's quartic. Think of it, quartics, it's like a bum. If you're sitting down, it's a bum. Okay. Parabolas are more like belts. So over here, am I going to go normal or downwards? Have a look. Downwards. Okay, good. Why is it downwards? Because I've got 3 negatives, and that's a positive. And then negative and a positive is a negative. Down. So it's gone something like this. However, we've got to be careful in what they actually look like. First of all, what feature are we missing, Amy? What haven't we? What also do we need to plot? The turning point and the y-intercept. Let's have a look at the y-intercept. Okay, x has become zeros. 3's in the front times a 3 cubed. What's 3 to the power of 4? 81. Okay, so look for 81. Remember, this is a sketch. You do not need to get your ruler and do 81 centimeters up. This is a sketch. Look for 81. We are going upside down because it's a negative. So I'm going to go like this. Okay. This is a sketch, remember? I'm going to come down. I could have gone through here and then gone like that. As long as you connect the dots. But this is important. When it comes down here, it doesn't come down like a straight through. Think of it as a power of 3. What are our graphs with the power of 3? They're like cubics. So you when you come down, you kind of do an inflection. Okay, so you've got an x, like a cubic in there in a way, and another root that's by itself on the outside. Okay. You can have variations of this. As long as this is sort of going straight through, this is sort of deflects. And it's got that weird quartic shape to it. It's still a really wonky W. Okay. Okay, let's do some solving. Okay. You might be asked to, in the test, to solve this. Px equals 0. This is just going to change it to 0. But what can I do to start with the next step? What's Nathan?
Can you take x squared out?
You can take x squared out. If I take x squared out and read out what needs to be in here to make it x4 if there's an x squared at the front? An x squared. What needs to be in here is 8. There's x squared at the front. In here to make a negative 9x squared. What's missing?
Negative 9.
Negative 9. Okay. Once again, we've established our null factor law. Big fat 0 over there. First one is a 0. Second one's a 0. What's the square root of 0? 0. X squared equals 9. X equals square root of 9. X equals 3. And what's my mistake?
It can be plus.
Can be pluses or minuses. The square root. Okay. Okay. Just as Nathan said we could factorize an x squared out, what can we do with here? Yeah, let's try that. It may or may not work. It's different to my notes. Could work there. X plus 1 square root of 2. But I've got x plus 1 square root of 4. Jesse, what goes inside here so that I have a total of 4 x plus 1s? How many do I put in here for the first root? 2. Okay. What's missing in here, Hudson? 5x plus 1 squared for the second term. What's missing at the end? Negative 9. Okay. That's going to be 0. I just didn't put that at the front. It should be there. Let's see how we go. Let's go for a walk. X plus 1 squared could be the 0. X plus 1 squared minus 9 could be the 0. What do we do when I have something squared minus a 9, Amy?
You made it 9 to 95.
Oh, you can? You can.
And then square root to 9.
Excellent. What do we need to make sure of? Plus minus of 3. X equals plus minus 3 with a minus 1. What are my two answers, Gabe? I have a positive 3, take away 1.
2.
And the next one?
Negative 4.
Good. Okay. Over here. Harry, let's do this one. Opposite of square.
Square root.
Square root, which kind of goes. What's the final answer? Negative 1. On my notes, I've got it differently here. Okay. Is everyone going to the athletics on Friday? Okay. With this one here, we're going to solve it with a substitution. What's an appropriate substitution that I can use to make this easier for us? Okay.
X minus 2 squared is equal to A.
Good. Okay, so not just a is x minus 2, but x minus 2 squared, because there's a lot happening up here. So I can now replace an x minus 2 squared with an a. So this a here is x minus 2 squared, and then it's squared again to make the 4. Over here, this here, that's our a. So it's just normally a 5a. Okay. We have a trinomial. How can I break this up, Tim? How can I break this up?
Minus 4.
What are the letters in the front? And what's the numbers at the back?
1. 1.
1 and 4? And what type?
Both.
Thank you. So remember, once we're done with that, we've got a minus 1 a minus 4. Once we've broken something up, we can now reintroduce the real thing. So that's the first bracket and the second bracket. I'm choosing to use square brackets because there's a lot of curves in there. Okay. I'm going to use, or you could do it whichever way possible. Over here, as Amy did, we just did a backtracking. But you may also, what's the other way we can solve this? What do you notice about the numbers 1 and 4? Okay.
The perfect squares.
The perfect squares. So that's 1 squared. 4 is a perfect square, which is 2 squared. And remember, perfect squares the first square gets separated. We have a second square here and here. But what's the difference between them? Correct. Thanks, Maya. One's a plus, one's a minus. That's just for the first one. For the second one, we do it again. Once again, we break up the twos because they're a square now. One's a plus and one's a minus. X minus 3, x minus 1, x, and x minus 4. Don't forget it's greater than 0. But we haven't solved anything yet. Okay, x minus 3 is that x equals 3. X minus 1, x equals 1. Got 1 at 0 and 4. We have a quartic. What type of quartic do we have? Do we have the normal one or a upside down one? If I'm looking at this line here. Okay. I have a positive x times a positive x times a positive x and a positive x. Okay. So it's going to be a normal quartic. It's going to do this. Cut through, cut through, cut through, cut through. We're only interested in greater than 0, which is this bit, which is above sea level, there, there, and there. Okay. I'm not going to include our zeros because we want greater than 0. This first section here, how do I express that? X is? Almost. Why? What's the correct answer? Less than 0, good. Okay, this one in between here and Rita. How do I express this hill in x values? So I'm walking up here, but I can just cut across here with my x's. X is greater than? What number? 3 is over here. We want to go behind 3. So we want to go less than 3, but greater than? Good. Okay. We don't want to include the zeros because if I color that in, I'm now on 0, which would mean that that's not involved. And lastly, say, what's my last x?
X greater than 4.
Excellent. Okay. Okay. All right. Do you guys need a break? I've got 1, 2, 4 pages left. Okay. We're going to use, I'm going to stop recording because we need to go on CAS. Everyone get your CAS out.